Let's go.
Think it's done, Mater to pray, Labor Day, was jumping Carburetor Canyon.
Jumping Carburetor Canyon?
No way. Yes, way. You remember. You was there too.
What?
Ready, buddy?
Right.
Okay, get it in.
That's it. That's all we got. So the big question is, does he make it? Does he make it to the other side of Carburetor Canyon? By the way, did you notice anything about the landing over here? It's the front of a car. And you got the grill here and the fenders here, stuff like that, a little hood ornament, whatever. But yeah, there's a ramp over there. So the big question though is, does he make it?
Yeah.
Cliffhanger, a math cliffhanger. Wow, that's pretty cool. We're gonna figure out if Pixar got it right with what they did. But before then, we got to do a little bit of work. Got to help you out. What shape do you think his trajectory is going to look like? What shape that you're familiar with? Come on, put it into words. Arch. What's a more, parabola? Yeah, parabola. All right. Now we're not going to worry about air resistance and things like that, or the winds coming out of the north, whatever. We're just going to calculate parabola and see if we can't figure out if he makes it. So there's a lot of things to discuss on the way, and I want to go over a few reminder things, etc. Let's start with example A here, and remind ourselves of some vocabulary first. So, for instance, where's the vertex? What's the vertex in all this stuff? One more time.
The vertex is at the middle of the groove.
All right. So the vertex is at the middle. It's going to be where this thing kind of turns around. So the vertex is going to be right here. So that's a point that I'd like you to be able to find. What else would be a place that I'd like you to be able to find? Well, this point over here, do we have a name for that? Yeah, it's our y-intercept. So our y-intercept, and we're going to get that by setting x equal to 0. So, okay, that's not bad. And there's two more points that you're going to be asked to find, which is going to be your x-intercepts. So your x-intercepts are going to be here and here. To get your y-intercepts, you're going to set something equal to 0. What is it that's going to equal 0? X equals 0. Good. And to get your x-intercepts, set y equals 0. Now, we don't really have a y here, so what am I going to do about that? What is it? Yeah, f of x is my y, right? So a little bit of interchangeable notation there. Let's see if we can't find some of the important points here. This one's kind of a nice one to work with because it's already set up in what I call vertex form. So example A. Let's see here. We've got f of x equals 3 times x minus 8 squared minus 5. What I would suggest is you start out by trying to find the value of x that makes the squared term equal to 0. And what do I mean by a squared term? I mean that term inside the parentheses. So this part right here, what's going to make that equal to 0? 8, right? If you put in an 8, 8 minus 8 is going to be 0. So let's start out with the vertex. The vertex is as small as it's going to get. And when you're squaring 0, you're not going to get anything smaller. So that's going to be when x equals 8. Now let's do a little thought experiment. Einstein was famous for his thought experiments. They call them Gedanken experiments. If I put in an 8 here, what will I get for f of x? Well, 8 minus 8 would be 0. Squared is still 0. Times 3 is still 0. But then we got the minus 5. So minus 5. And so you can pretty much just read off the graph, what your vertex is if you have it in this form. And that's why we call this vertex form. So let me kind of put that up above. This is vertex form. And that's going to be f of x is x times a minus h squared plus k. And that's going to have a vertex at h and k. So it's pretty nice. You can just read that information right off of the equation, the graph. You don't have to pull out your graphing calculator or decimals at all. We're just going to read that thing. So where I stop the video here is going to be the vertex of Lightning McQueen's parabola. So we're going to use that to try and help figure out if he makes his jump. But let's turn our attention back to some more applied things here. And that is, we've got the vertex. How about if I wanted the y-intercept? Those are a couple easy points to get. If I set if I set x equal to 0, well, I'm going to have to do a little bit of work here because it's not as easy as setting x equal to 8. 0 minus 8 would be negative 8. When you square negative 8, what do you get? A positive 64 times 3 is 192 minus 5, 187. So 0 and 187. So I can mark that up here, 0 and 187. Let's see, what else? Now we need the x-intercepts. Set x equals 0. So to get the x-intercepts, I'm going to set y equal to 0, or in our case, f of x. Let's do that up here. That's going to be 0 equals 3 times x minus 8 squared minus 5. Now, it's really convenient that we have this in this particular form, because if we didn't have it in this form, we'd need to use the quadratic formula to get the solution here. But if I got it like this, personally, what I would do, I'd add 5 to both sides. You get 5 equals 3 times x minus 8 squared. What else could I do to try and keep on narrowing things down and solve for x here? Anything? Yeah, divide by 3. And when you look at the left-hand side, you're like, uh-oh, this is not a nice number. That doesn't go in there evenly. So I get 5/3 equals x minus 8 squared. Looking good there. Gio, what can I do to finish this up? Um, could, but that would end up probably needing the quadratic formula, and I'm trying to avoid that. Ola? Square root both sides. All right, we can take the square root on both sides. So let's do that. Square root of 5/3 equals square root of x minus 8 squared. Okay, there's something missing. If we just left it like this, I'd be missing a point. Yeah, it's sometimes easy to forget, but you need a plus or minus there. There's two solutions. So what happens there? Well, I get x minus 8 equals plus or minus square root of 5/3. I still haven't gotten x by itself. Josh, what else do I need to do to get x by itself?
Add the 8.
Add the 8. So I'm going to put that 8 out in front over here. 8 plus or minus the square root of 5/3 equals x. Yay. So I'm going to extend my t-table just a little bit, give myself some extra room here.
when y is 0, one solution I got was 8 plus the square root of 5/3. Leave some space here. And 0 and 8 minus the square root of 5/3.
Now, if I was graphing this on an exam, I don't know what 8 minus square root of 5/3 would look like. I'd have no idea. Well, maybe that's not quite true, but so what could you do if you had to graph this reasonably accurate? Yeah, convert it to a decimal form. So take out your calculators, and I'm going to show you yet another trick here that'll save you a little time, I hope. And I see you're busting them out, so let me just open up this way. Maybe a little easier to see. So let's type in the 8 minus second, and then the x squared key, square root of 5 divided by 3. And I get something like this. Now, I'm not going to be looking at your graph with a magnifying glass or a microscope or something like that going, no, that was, 6.708, and you were supposed to give me 6.709. I mean, just round it off to the nearest tenth of a decimal place. I'm not going to look for anything any more accurate than that. Probably even not quite that accurate. So this is about 6.7. Now I need the other one. And so here's a nice little trick that you can do to get the other one. If you hit the second key and the enter key, it'll pull up your previous calculation. And what do we got to do?
Change it to plus.
Yeah, just got to go back and change it to a plus. So, a little quick trick there. Nothing big. So the second one's about 9.3. All right, so about 9.3. So if you had to locate these on a graph, at least you got about or ballpark estimate of where they're going to go. But as far as the exact answers, I'll probably have a little blank asking for the x-intercepts, and I'll want the exact answers. This is the exact answer. Just a heads up, Desmos I don't think has a plus or minus key. So you're just going to have to type it in twice. Sorry. Wish it was different. All right, so we got all three of those. That's great. Let's look back here just for a moment. There's another form that we can write this parabola in, and it's called standard form. So let's take a look at what standard form would look like. So standard form. Standard form is going to be y equals ax squared plus bx plus c. And if I've got 3 times x minus 8 squared minus 5, how am I going to get this to look like this? What would I do? How? Right? Square out the x minus 8. All right, let's start there. So it's going to be 3 times x minus 8 times x minus 8. And Sage suggested that we focus on these first. So let's square that out and see what we get. So it's going to be 3 times x squared minus 8x minus 8x again plus 64. I still have my minus 5 here. Now I can combine like terms. That's going to give me 3 times x squared minus 16x plus 64 minus 5. What next? Distribute the 3. Does the 3 distribute itself to everything here or just everything in the parentheses? Just into the parentheses. So 3x squared minus 48x plus 192 minus 5. And I would hope that you would simplify that last little bit here. 192 minus 5 gives me my 187. So y equals 3x squared minus 48x plus 192.
Nice. 187, sorry. 187. Yeah, 187. Thank you. All right. Looks good. Looks good. Are you okay with kind of our little reminder, warm up about parabolas? What we're building towards is trying to figure out an equation for Lightning McQueen. Now, there's one last little part to this that I want to help you out with. A lot of times you'll start out with something in standard form, but boy, it's really helpful to figure out what it looks like in vertex form. So my goal for you is to be able to go from something like this to something like this. Now let's do it with a new problem down here. Example D, we'll take that one. And before I get into this, I'm going to have to play around a little bit with something that hopefully you picked up last semester, but maybe you didn't, maybe you did, called completing the square. Take a look at this term here in the parentheses. X squared minus 16x plus 64. Where did I get this? That originally came from x minus 8 squared. We're going to have to be able to reverse engineer things. We're going to have to be able to go from something like this to something like this. So let's remind ourselves some of that work. So this is completing the square. And let's take a look at x plus 5 quantity squared. Well, a lot of you could probably do this in your head, and if you can, that's great. X squared plus 5x plus 5x again plus 25. Looks like this. But here's the kind of problem you're going to be faced with on an exam or something like that, or maybe as part of your homework. You're going to be faced with something like this. You're going to have to figure out, what do I put here so that this is the right polynomial to be the square of a binomial? So our clues here. Well, we want to come up with the 25. Where did I get the 25 from in the first place? Yeah, 5 squared. All right. If I got a 5 squared there, how am I going to look at that 10 and come up with the number 5? What do I have to do to come up with the number 5? Half. You want to divide it by 2. Notice what happened here. You had that middle term twice. There's your 5. I had it twice. So to undo the twice, you're going to divide. So overall, there's going to be 2 steps to complete the square. So let's take a look at those steps. So you got y equals, let's see, I don't want to put y equals. You got a times x squared plus bx plus something equals something squared. So first step is a must equal 1. We're going to have to get rid of any coefficient that's in front of this. Second step, we're going to have to divide b by 2. So divide, we want b over 2. And the last step is we're going to square this result, b over 2 squared. So that squared term is going to go here. And so we're going to make this a 1 here real quick, or actually just get rid of it if you don't mind. Hasta la vista. There we go. It's all gone. So we're going to just jump down to this part right here, but we have to keep this in mind as well, that the coefficient of your x squared term is going to have to be 1. These terms are going to go here and here respectively. A couple practice problems, and then we'll work on example D. Let's try x squared minus 18x plus something equals something squared. So this first one's going to be the easier of the two examples you're going to get. You've got a coefficient of 1 here, so that's good. So our first step is going to divide negative 18 by 2. And what do I get? Negative 9. Great. Let's take that negative 9 and square it. So, let's see. Yeah, I guess I will stick it here. So negative 9 squared gives me what? Positive 81. Thank you. These two numbers fit in, first of all, right here. You're going to get your 81. And secondly, this one is going to go here. But I hope you do more than just write negative 9. What's wrong with just negative 9? When you square negative 9, you're going to get the 81. You're not going to get the rest of this. So what am I missing? X. You're missing that X there. Okay. Of course, I did the easy one, so that means I'll give you the hard one, right? Let's take a look at y squared plus 7y plus something equals something squared. Now, even though it's not a nice even number there in the middle, we're still going to do the same things that we did just a moment ago to complete the square. Point of reference here. The coefficient of your y squared is 1. That's good. If it's not, then there's extra work you got to do. So I need to take half of what number? Half of 7. Does 2 go into 7 evenly? No. It's just 7 halves. That's it. Not much we can do there. You could do a decimal value. I'd rather not have decimal values. What do we get when we square 7 halves? 49 over 4. See if you can't fill these in. What goes where? What goes where in terms of completing the square? Jaya? What should I put here? All right. So right here, we're going to put the 49 over 4. Great. Alex. Or excuse me. Yeah, Alex. What am I going to put here? Perfect. So y plus 7 over 2 squared. Perfect. Great. And that's it. That's all we needed out of that. The goal for this, the reason we're looking at this is because we're going to want to take equations like this and complete the square to put it in that vertex form. And when we do that, then we'll be in great shape. So do a little bit more work here. You know, maybe we'll do this problem kind of twice in various ways. And then I'll let you solve the fate of Lightning McQueen. All right. So let's move on to example D. F of x is 2x squared minus 4x minus 4. If I want to know what the vertex is, then one way to get at that is to put it in this completed the square form. So I'm going to start this way. Y equals 2x squared minus 4x minus 4. And this doesn't, to me, look like a nice perfect square trinomial. That is, it doesn't look like x squared plus 10x plus 25, which is a nice perfect square trinomial, because it's a square of this binomial. So I'm going to make this a perfect square trinomial. And I'm going to start by moving the 4 just to the other side, just to get out of my way for the moment. So I'm going to complete the square on the left-hand side. Now, when something changes sides, what else changes?
Sign.
Changes the sign. Thank you. So that's going to be a y plus 4. Y plus 4 is 2x squared minus 4x. I want to complete the square on the right-hand side, but what did I say we needed before we complete the square? Coefficient of 1. Thank you both. Yeah, I needed a coefficient of 1. So what I could do here is I could get rid of this 2 in a sense by factoring it out. Now, don't factor out the GCF. That's not what we're doing. We're just factoring out 2. And if I factor out a 2, what's left behind? Meredith, if I take out just the 2, what's left behind? Do you agree? Thank you. Thank you. So x squared minus 2x. And let's put a little plus something in here. This is kind of like the player to be named later and all these wonderful trades, etc. So we're going to want to figure out what number to put in here to complete the square. What number makes that a perfect square? And so you're going to play around with this middle term right here. What number would you put in here to complete the square? Don't worry about anything else at the moment. What number would you put here to complete the square? Got a couple hands. Yeah. Got a couple ones. Got a one's going twice. -1? Do you do a -1? Let's take a look here. So to complete the square on that, so complete the square, we're going to take half of -2. And you're right, that gives me -1. What happens when I square -1? Yeah, you get a +1. So it's that +1 that's going to go there. So I hope you caught how and why that became positive. Now here's the tricky part. I'm working with an equation, right? I've got to make sure that both sides of this are balanced. If I put a 1 on the right-hand side, I should put something on the left-hand side to keep it balanced. What would that be? And it's not a 1. Ooh. Eva? +2. Y +2. Yeah, because that 1 is in parentheses is getting multiplied by a 2. So 1 times 2 is going to be a 2. So if I put 2 on or put a 1 in here, I'm really adding 2 to the right-hand side and I have to add 2 to the left-hand side to keep it in shape. So great. All right. This is where I wanted to be. Let's clean this up a little bit. The left-hand side is just y plus 6. I don't need to bother anyone about that. But the right-hand side is now a perfect square. So, Enora, what do I square to get the right-hand side? What binomial do I square there? Just a 1? Need an x plus 1? So x plus 1 times x plus 1, then I don't think I would get a negative in here. So The trick when you're completing the square here is that this number goes here, and this number is going to go here. So it'll be a -1. So x -1. So you use both of these numbers that you do in this little side step, and you've completed the square. Last thing I'm going to do is I'm going to move the 6 to the right-hand side. And Nora, are you okay with that step? Okay. Nice. What's the advantage of things here? What can I do now that, yeah, hey, this is good. Yeah, the vertex. It's a vertex form. So, Robert, what's the vertex? Very close. Somebody. Ah, there you go. So the nice thing here is I've got this in vertex form. 1, -6. Cool. Now keep in mind, you've got two forms of this equation. 2 times x -1 squared minus 6, or y equals 2x squared minus 4x minus 4. The next easy point to get is where this is actually 0. In terms of, well, excuse me, not where it's 0, but the y-intercept. So for the y-intercept, I'm going to set x equal to 0. Which of these two equations are you going to use? The one on the left or the one on the right? You're going to vote for the left? You're going to vote for the right. All right, so we're pretty much split down the middle, right? Somebody cast a deciding vote. Which one's going to be the easiest? Which one would you do?
Oh yeah, you can do whatever one's easier.
Yeah, I would do which one is easier. To me, one of them is screaming out as being much easier. If you're going to put in a 0 for x, really? What happens if you put a 0 here? And if you put a 0 here? Both of these terms disappear, right? And you can just look at this. What's the answer when you put in x equals 0? -4. So that's kind of cool that you can use that one there. But now we want to find, well, all right, what's the y-intercept? Or excuse me, what are the x-intercepts? And for that, you're going to set y equals 0. You've got your choices here. If you put y equals 0 here, you're going to end up using the quadratic formula. This doesn't factor. You're out of luck. If you put y equals 0 here, you can use the square root property. So, I don't know. I like using the square root property. It's a little bit easier than all the messing around with the quadratic formula. I hope you remember that. Let me write it down here just in case you need a refresher. -b plus or minus the square root of b squared minus 4ac all over 2a. A lot of people will leave that -b hanging. So if you run through this with this, you'll end up getting the same solution. But in my mind, it's easier just to put in a 0 right there. Let's see what happens, how that one looks. Help me work through it. So let's see. Zach, what would you do first? Add 6. Good. So we get 2. That means 6 equals 2 times x minus 1 squared. Looking good. Then what? Divide by 2. We get 3 equals x minus 1 squared. That's looking decent. Gavin, what next? You mean square root, right? Yeah, square root of 3. And I'm sure that Gavin and everyone else remembers we need a plus or minus there for the square root of 3. Last but not least, you want to get x by itself. So you move the 1 to the other side. When it changes sides, it changes signs. Thank you. All right, so we got 1 plus or minus the square root of 3. equals x. So we got 1 plus the square root of 3, and let's give ourselves a little room. 1 minus the square root of 3. You can bust out your calculator. This would be about 2.7, and this would be about negative 0.7. So those would be your x-intercepts. So you got your x-intercept, your y-intercept, etc. Hey, you're golden. Now, this process of completing the square is something that I want you to do. I want you to have that skill set. What I generally do is I'll generally give you the equation in both formats and let you run the problem. But as a separate problem, I'll give you another equation. I say, all right, take this and just complete the square. The reason I separate those is because if you make a mistake here, you're not going to get this part right. So I give you this part right, have you graph a parabola, and come up with these points separately from completing the square, because to me, they're different problems. All right, so that's all the points that we needed here. There is a couple more things to finish things out so I can let you start working on Lightning McQueen. If you look at this little handout, then one of the things it mentions here is a little formula. And that's going to give you the x coordinate of your vertex. So let's look back at something like this. So this is example B, or example B, even more. We had y equals 2x squared minus 4x minus 4. If you want the x coordinate of your vertex, you can get the x coordinate of your vertex through this formula. Negative b over 2a is the x coordinate of a vertex. Okay. Let's see if we can't find that from this right here. X equals negative of b over 2a. What's b in this case? Negative 4. All right, so the negative of negative 4 divided by 2 times a. What's a? 2. So you end up with a negative of negative 4, which is 4 over 4, or 1. Great. That's the x coordinate of the vertex. But typically speaking, you need both coordinates. You need the x and y coordinate. So what would I do to get the y coordinate?
Put in 1 for x and y equals
Yeah.
2x squared minus 4x.
Yeah. So there's your x coordinate. Your y coordinate is just going to be y equals 2 times 1 squared minus 4 times 1 minus 4. That's going to be 2 minus 4 again. And guess what? You're going to get negative 6. So our vertex is 1, negative 6. So that's not too bad. Suppose this is how you started out the problem. You needed to put it in intercept form, in vertex form. Well, we're almost there. Remember, vertex form is going to be y equals a times x minus h squared plus k. And we just found h and k. So the only thing left then is, well, what's a? How would you find a? That a there is the same as that a up there. So I know that a is 2. And I'm going to have 2 times x minus 1 squared plus -6, or better yet, just 2 times x minus 1 squared minus 6. I don't know. Maybe that's a little bit easier for you. What do you think? Does that work? Should I make it even easier, or are you bored with the stuff already? It's up to you.
Make it easier.
Make it easier? You're sure? Okay. I noticed a little hesitancy there. I wouldn't want to voice this on you. Take out your calculators. We're going to make this even easier. Now, not to say that you shouldn't know all 3 of these forms, but let's finish this up. Let's plug in our equation. So if there's something there, just clear it out. We want 2x squared minus 4x minus 4. I'm going to want to graph this, but a lot of times you don't know where to start. You're looking at this going, yeah, I have no idea. So kind of a good place to start sometimes, if you don't know anything else, is zoom standard. That is zoom 6. That's going to take and set your window from -10 to 10 on the x-axis and -10 to 10 on the y-axis. So again, zoom and then 6. That's zoom standard. And we get something like that. Now, you can kind of eyeball this, right? And you look and you're counting 1, 2, 3, 4, 5, 6. It looks like 6 and 1. If you're unsure, hit the trace key. You hit the trace key, and well, we want to see what happens when x equals 1. So type in a 1. X equal 1. It'll open up a little thing on the bottom of your calculator. When you press the enter key, it'll give you the y coordinate. And bam, it looks like you're right there. So now you got x and h. And of course, you had a because you had a all along. So wow, that's even better. Nice. If you really needed to, if it wasn't clear at all that you couldn't read what was going on with your vertex here, what you could do is calculate the minimum. So you hit the second key, then calculate. You want the minimum, or it could be a maximum if your parabola opened upside down. In this case, it's a minimum. It's going to ask you, well, where should I look for a minimum? Go a little bit to the left of your vertex and press enter. It's going to put a left bound there. Go to the right of your vertex, press enter again. It doesn't matter how far. And then it's going to look for a minimum point in between here. Now, it might not get it exactly, but it'll probably be rounded. You'll probably be able to see it and round it yourself. You need to press enter one more time, and bam. So like I said, it didn't get it exactly, but it's pretty close. I mean, certainly that would round to 1 if you're working with anything less than 5 or 6 digits. Yes.
So where the type of square over the y equals, so you do 8, so what the 2 x's are.
What are you looking at?
So on the graph, when you type in,
Oh, the tracing part?
yeah, the trace part.
So let me go back to the graph. If you hit the trace key, then you can kind of zoom around with this. Now, it's tough to necessarily land on the exact point you want. I mean, if you take a look, I'm at 1.06. I'm like, you know what? I just want to see it when x equal 1. And you type in a 1, and bam, there you go.
Yeah, I was more referring to like, because when I tried to type in 0 to get those two, it didn't pop that up, it popped it up on the y axis. Get those 2 x axes.
Let me look at your calculator and see what you got going after
Yeah.
I get you guys going on this stuff for Lightning McQueen. So you've got a handout for this stuff. I'll put you in groups in just a minute. But what's going to go on is this. You've got Lightning McQueen jumping over Carburetor Canyon. And there's a little dot, not very visible, at least on most medium. But there it is. So somewhere in there, there's the vertex. And what I want you to do
is I want you to try and come up with the equation here. Now, I want you to come up with the equation in two forms. I want you to come up with the equation in vertex form. So that's going to be x minus something plus something, or x minus something squared. So let's do x minus a negative 2.5. So that double negative is going to become positive 2.5. And then I'm going to hit the square key outside the parenthesis. Don't square just the 2.5. So that's not too bad. And then I got to add something. So add maybe 50. And I overshot it a little bit intentionally. But you can play around with what you think the vertex is. And then you can kind of try and dial this out a little bit to match the jump and see if he lands it. Is he going to land pretty close to the lip of this thing or not? So that's what your job is. Now, there is another form of a vertex, or excuse me, of a parabola that you could do, and that is just by using this value of a and taking note of the roots. So that other form is kind of hinted at right here. You're just going to do a times x in the first root and then x in the second root. So if we had to guess here, what would be a good guess as to the root of this polynomial? And by root, I mean where it crosses the x-axis.
0.
0 and -5. All right, so 0 and -5. If those were our roots, then I could write an equation like this. Y equals a times x minus 0 and x minus -5. Well, what happens to the minus -5? It becomes positive. X minus 0, I don't need the minus 0, so I'll just write that as x times x plus 5. And that's another form of the equation. All you got to do then is figure out what a is. And I made it easy here because I gave you a slider for a. So there you go. All right, let me let you work on these things. Let me tell you what, let me give you a quick break, and then I'll actually ask you to work on things in your groups. I'll get you in the groups when you get back. So please get back on time. So what we're going to get here is kind of going to depend on your estimate of the vertex. So, giving kind of a rough estimate, to me, it looks like about negative 2.3 and say 41 is not a bad rough estimate. So if that's our estimate, then I could fill it into this equation this way. Y equals something times x minus negative 2.3 is going to be x plus 2.3 squared plus 41. And then we're going to need to determine the value of a based on what the graph looks like. So let's flip back over to here. I'll type in 2.3. So that's going to move the parabola to the left. If I change the 50 to a 41, that should move things down a little bit. So it goes pretty close to, the vertex. I'm not giving you the exact answer here right yet, but then you can start shifting this around a little bit until you get something that looks pretty good. So for us, or for me, and maybe I should go 2.4. No, 2.35. All right, that's as close as I'm. 3.3. Okay, fine. 3.3. 3.3, and then maybe 40.5. Looks pretty good. And let's see, are we coming pretty close here? Is that looking pretty good? Maybe I should widen that a little bit. So something about like that. So right now it's not looking too good for Light and McQueen, right? Because he's going to land below this point here. But let's stick with this. So that form of the equation would be negative 7.35. Y equals negative 7.35 times x plus 2. We went 3.3, right? 3.3 squared plus 40.5. So that's that form of the equation. Now the root form of the equation, well, let's take a look back at our graph.
our root form of the equation is going to come from these 2 points. And you just kind of click on them. All right, now this one, I'm going to mercifully round to the nearest 100th place. So we've got an x equals 0 and an x equal negative 4.68. So it's going to look like this. Y equals a times x minus 0 and x minus negative 4.68. And we can go ahead and try and determine a value of a that works in this formulation. So let's see. There, then 4.68. Let's shut off this graph, turn on this one. And we're looking pretty good. Yeah, I think that looks pretty good overall. So which one's easiest to come up with? Well, it's up to you. It's personal preference here. So both of them are looking pretty good. That part is personal preference. But are these two equations identical? Well, to find out, there's 2 things you could do. Did anyone figure out one of them? What's the easy thing to do to figure out if these 2 equations are the same?
Look at the graph.
Yeah, look at the graphs. See if you're getting the same graph from both of them. So you turn on both graphs at the same time, and they're looking pretty close. I mean, you see a little bit of a shade of orange peeking out from the right side of this parabola, but they're looking pretty close. So I'm thinking that's good. The other way that you could work this would be to square this out, distribute the negative 7.35, add the 40.35, and see if you get the same thing when you multiply this out, which, let me look back here. That was negative 7.35 times x plus 4.68. All right. So, which one's easiest is kind of, a little bit of preference, but you can check it. What was McQueen's trajectory as it crosses the x-axis? You had a couple different equations here. You could have used either one. Y equals negative 7.35 times x plus 2.33 squared plus 40.5, or y equals negative 7.35 times x plus 4.68. But either way, what happens to Lightning McQueen's y coordinate when it touches the x-axis? What's the y coordinate when it hits the x-axis? 0. So you can either solve this one, x plus 2.35 squared plus 40.5, or you could solve this one. Actually, this should be a 0 here. Let's clean that up a little bit. There we go. 0 equals negative 7.35 times x plus 4.68. Which one do you think is going to be easier to solve? The first one or the second one? First one? This one? Well, I mean, you can solve it. You move this over, divide by negative 7.35, take the square root on both sides, plus or minus, blah, blah, blah. But this one, you've already got it, something multiplied together and you get 0. So this part is 0 when x equals 0, and this is 0 when x equals negative 4.68. So I kind of like this one. If you wanted to put your equation in standard form, what would you do? I think at least you figure that one out. What do we do to put our equation in standard form? Sure, sure. What numbers did you get? Okay, so one way to do this is to multiply this all out. 3.5 times x plus 2.35 plus 40. The way you'd have to do this is you would start here inside, multiply this out, so yeah, that means FOIL, collect like terms, then distribute the negative 6.6, and finally add the 40. So, yeah, a lot of work.
might be a little easier to do it with this form because all you got to do is distribute here. So that would be that. Now, there's a lot of different models that you can use for data. And kind of a new feature that they have on Desmos that is really cool is this one here. So if you opened up the data tab, did anyone get down here to open up the data tab? No, no one got that far? All right. If you open up the data tab, then you can see a couple points on our graph here. And I've got the program or the coordinates of this programmed in. So click this little button here. It says add regression. Now, does a line look like it's a good fit to these 3 points? Is that a good model for our data? This straight line models, say, this point, and this point. Is that a good model? Probably not. How about a cubic equation? Does that seem to follow the path here by this parabola? Well, it goes through all 3 points, but it doesn't really follow the path very well. And if you look long enough, you say, oh, we got a quadratic regression. And wow, that does pretty good, doesn't it? Pretty nice. And here's your equation right there. In fact, the the last term here is a 0, meaning it just goes right through here. So what was your conclusion? What do you think? Did Lightning McQueen make it? Yes or no? All right. Let's turn to the guy with the answers.
Didn't make it. Come on, guys, let's go.
Sorry, Lightning. Didn't make it. All right. Which shocked me. I was like, no way. These always have a happy ending. I was totally disappointed. Yes.
You posted both of them don't have data unless
I was updating these until the very end of class, or the very beginning of class. So if they don't, my bad. I will post the correct ones. But last one, no, he didn't make it. Sorry. So if you have any feedback as to some more things I could do to make this a little bit easier and clearer to follow along, that's great. But I'm hoping you're seeing some of the things that I'd like you to get. There's a couple different formulas, versions of the root and stuff like that, or excuse me, versions of a parabola that we can work with. There's your vertex form, your root formula, and then of course your standard form. So there's 3 different forms. All of them have their convenience, you know. With the standard form, it's easy to see what the y-intercept is because if you put an x equals 0, it's just c. So the y-intercept is right there. The root formula, that's pretty nice because you know exactly where it crosses the x-axis. And the vertex formula, you know exactly what the vertex is. So all of these have different benefits and challenges. Just kind of depends on what works for you, what you need in this situation. The other things that we went over are, you know, how to find the x coordinate of your vertex with this formula. That's something I would expect you to know. You know, and with this formula, you don't necessarily need to even look at the graph. You can look at the graph to figure out the vertex, but if I give you a graph with large coefficients, you're probably not going to be able to figure out how to use a window big enough to see that. So do have this formula in mind. And you should be able to complete the square. This procedure right here, where we started out with a parabola in standard form. I moved the 4 over. I factored out the coefficient here. We completed the square, and then we had it in vertex form. So from there, you pick whatever formula is easiest, and then you can plot all these points. Comments or thoughts on section 3.1? Okay. Let's take a step back and do section 2.8.